We will open our final model now. Workbook open, O5 sample project final model. And look at the final results. Let's start with the top level, our overall tunnel project. We go to properties and look at the results for base cost, risk, escalation, base cost plus risk, total project cost. So for each cost component, you get a distribution function here. The total project cost, for example, is between 1.1 and 1.3 billion US dollars. You can change the view to million dollars, so it's easier to read, 1.1 billion to 1.3 billion. You get this information on all levels of the WBS. So if I click on owner's indirect cost, I have the same structure here for the construction contract, for the tunneling works, systems, civil works, and so on. Now let's look at some diagrams. If you go to evaluation, you get a more detailed look on the distribution density and the distribution functions. You can go to cost outflow, go to stacked, and you see when you're going to spend your dollars in terms of base cost, identified risk, unknown, and escalation, or you can just look at the total numbers. Then you can look at a disk chart that gives you a visual idea of what portion of the cost is in each group. You can get a bar chart broken down into cost components, a tornado diagram, and a range impact diagram. Just select identified risk and cost elements here. You can also export your cost to Excel or to a PDF. There are different ways of doing that. I will just show you one option real quick, and that is trying to reproduce the curves that I've shown you at the very beginning of this video. We right-click on total project cost, copy value to clipboard, go to our Excel template and paste them here. We do the same for BR, paste the values into Excel. We do the same for the base cost, paste our values into Excel, and we will also add the deterministic base cost, which are 747,661 million US dollars. This is a very similar graph to what we have seen in the beginning of this tutorial. We have all the distribution functions of the relevant cost components visualized in one graph. On this axis we have US dollar and millions of US dollar, and here we have the cumulative frequency. We can use this chart to find a robust budget for our project, or we can estimate our current budget in terms of potential for cost overrun or maybe even underrun. For example, if we want to have a chance of 80% of not exceeding our budget, we need to have $1.266 billion in our budget. This is the number that is most relevant to us. This was our RIAAT walkthrough for the integrated cost and schedule analysis. I hope you enjoyed the video. If you have any questions, please feel free to contact us. Goodbye.